Okay, definite integration and physical area. If you're asked to find the physical area between y equals sine x and the x-axis between 0 and 2 pi, you'd think, oh yeah, I know how to find physical area. That's the definite integral. And you'd go on your way and you'd say, all right, integral between 0 and 2 pi of sine x with respect to x. You'd integrate like a good boy or girl, have negative cosine x between 0 and 2 pi. You'd recall your unit circle coordinates. And when you're evaluating, you'll be able to do that without too many dramas. Minus cosine of 2 pi minus cosine of 0. Okay, we're all big boys and girls now, we should be able to do this. Cosine 2 pi, so here's 0 or 2 pi, looking for the x coordinate, which is 1, so minus 1, and then minus, what's cosine 0? Oh, that's 1 as well. We get minus 1 plus 1. I get an area of 0. What is going on there? Well, what's actually happening is when you do this definite integral, it's sort of like trapezoidal rule and the rectangle method. What it does, it considers this as a positive area and this as a negative area. So what that means for us practically is that if I want to find physical area, I'm going to need to integrate between 0 and pi, and then between pi and 2 pi. So this process didn't work. And I'll need to consider the two sections separately. So to find the physical area, I'm going to integrate between 0 and pi of sine x, and then between pi and 2 pi. A lot of the times I won't know which one's positive and which one's negative because I won't be able to see the graph. All I'll have is the function. So the way I'm going to get around this is by taking the absolute value of both of these definite integrals, okay, and add them together. The way absolute value works is if I have the absolute value of 4, it's 4. If I have the absolute value of minus 3, it's positive 3. Essentially turns whatever's negative into a positive and maintains a positive as a positive. Okay, so now I can go ahead and integrate both of these sections. I need to maintain the absolute value all the way until I have a number there that I can evaluate. Okay, it's going to be a little bit of hard work, but that's okay. Never shy away from a challenge. Cosine of pi minus cosine of 0. And then I'm adding absolute value of minus cosine of 2 pi minus cosine of pi. Okay, the absolute value signs can serve as a bracket as well, so I can get rid of one of those brackets in the left side. Okay, I'll scroll down so I can see my unit circle again. Minus, what's cosine pi? Pi's over here, so that's minus 1 minus what's cosine 0? That's 1. Yep. Plus minus cosine of 2 pi, which is 1. Minus cosine of pi, which is minus 1. Probably should have just used the calculator for this one, but I'll get there. So I've got absolute value of 1 plus 1 plus the absolute value of minus 1. I've got 3 minuses there, so that'll also be a minus 1. Absolute value of 2 plus absolute value of minus 2. Now I can get rid of these absolute value signs. So 2 plus this minus 2 changes to a 2, and I've got a physical area of 4 units squared. That 4 units squared looks a lot more realistic than the 0 that we got using the standard techniques. Okay, and just to summarize, okay, the process will be see if there are any x-axis intercepts between the bounds that you're integrating. So you'll set y equals 0, or you can graph it and see where they are. And if there are, you'll need to integrate each section separately and take the absolute values of each section. There's a whole heap of questions that you can attempt, so good luck.